I know they used to be 20, but with prices anymore, I don't know. So that's my house probably 4 hours ago. Main power on, main power off. Now, how much difference can you see between those two pictures? And they were just like a few seconds apart. I went into the laundry room, took a picture, flipped the power switch, waited a few seconds, and took a picture again.
Looks like down the bottom there, down to 60 and that down the very bottom.
Yes. And that's what, if you notice here, and I like playing on 6 meters, 50 megahertz. Or actually, yeah, there's 50 megahertz right there, because that's 100 megahertz. I do have something that's putting out quite a bit of noise. But it's hard to see unless you look really close. So I do need to go back and start slowly turning stuff back on. So the best way to do this, to make it easier for you to keep a little bit of hair if you have any, you turn off the entire power to the house, check if you see a problem, turn off every breaker, but turn the main breaker back on so that the panel is powered, and then do it one circuit at a time. When you see the circuit that causes the biggest change, figure out what's on that circuit and go start unplugging or turning things off on that circuit. If you do it kind of in that approach, it's a lot easier. If you just run around and turn everything off, it's really hard to double check because things may compound on themselves. So you might not notice the problem just when you turn one thing off, but if you turn everything off and then slowly turn back on, in my experience, it's easier to detect where the problem comes on. So HF, I've got some problems. 440 doesn't look a lot different to me. It's a little, but not a lot. So 2 meter band. As you can see, there is a little more noise, but not a lot because this is a lot flatter below the line over here, where here the peaks are kind of hitting the line. And I'd really like to know what this is because this is somewhere around the 220 band. But it's there, power and no power. LED lights. I'm going to tell you this little story that I did. This is the dumb guy here. New ham, don't know what I'm doing, but trying to do stuff. If I transmit on 12 meters, 10 meters, or 15 meters, and this was before the solar cycle started coming up, so it wasn't really good propagation, my radio would go deaf. I could hear signals before I transmitted. After I transmitted for 20 seconds, 30 seconds, I couldn't hear anything. My ears did not notice the noise level go up very much. So I'm like, something's wrong with my radio. It's broken. When I transmit, something's not switching back to receive right. So I sent it in to get repaired. And I spent $100 and some bucks getting my radio repaired. Finally get it back after, a month. Hook it up. Yay, it's back. Well, he shipped me the wrong microphone. I don't care. I'll swap it. Hook it up. Exact same problem. What's going on? Talking to the guy that repaired it. It's still doing it. I didn't see any problem like that. It worked perfect here. Here's all my test results. Trying to play around and figure out what it is. Finally figured out that the radio wasn't going deaf. The noise was increasing because I was watching the S meter. But when it's already, say, S8, noticing the difference between S8 and S9 is really hard to tell. But it can make the difference between hearing something and not hearing anything. I figured out that I had a motion sensor light switch in my basement that was triggering at those frequencies at 10, 15, and 20. When the radio would transmit, it would trigger the motion detector. and the lights in the room at the bottom of my stairs would come on. I put some cheap LED lights in there because kids going up and down the stairs, they would leave them on. I put the motion sensor and some cheap lights. That way it wouldn't waste electricity. The $100 and some bucks I spent on repairing the radio, which wasn't repaired, and shipping it, would have paid for all the electricity that would have been wasted if I'd have put decent lights in and left them on 24/7. That was LED lights. This is LED lights. See the lights on? See the lights off. Now, is there a big difference? No, but when we look down here again at the HF region, pretty good. It wipes out 6 meters when there's two in this particular room, which is our laundry room. I've got two little LED can lights I stuck in the ceiling because it originally had a 4-foot fluorescent. That's what it does. It wipes out 6 meters at my house. So I throw a fit when people turn on the lights in the laundry room. Kids leave lights on all the time. How many times have you heard me ask people to turn off the lights in the laundry room? Yeah, for those of you who do 6 meters, 6 meters can be on and off. You never know when it's going to work. And if it happens to be a time that you've got a DX station on and the lights are on, I get grumpy. Okay. We've been working on that. Now, network gear. This is not a great thing to show you, but you can see some network cables back there. This is a wiring closet for my network. Here, I'm in front of the closet, probably about 4 feet in front of the gear, because there was no easy way to turn it all off without turning all the lights off and stuff. You can see the noise level. How much higher is the noise level over here? I moved this device up close to it. So it moved 1.5 to 2 feet. These lines are in decibels, 10 decibels. So between like there, on the line to halfway up, that means it's a 5 dB increase. You just passed the test a little while ago. How much of an increase is, let's move it to 6 dB to make the math easier. How much stronger is the signal? 6 dB stronger? 4 times. It's twice and twice. Every 3 dB doubles. So that's 4 times stronger. Right here, see we're all the way up onto the 10, and this particular spot is much closer to this one. So that is almost 10 times stronger signal. That's from my network gear. Who in here knows network gear? Is Ubiquiti usually considered a fairly good brand for network gear? That's a Ubiquiti Dream Machine Pro sitting right there that you can't quite see. So it's, what?
It's like the Rigid tools. Like you go Home Depot and you buy Rigid, and then your link system is like Ryobi, and if you get, it says Rigid Marine.
Yeah. But my point is, this isn't the cheap Chinese junk that you can buy that you would expect to put out lots of noise. Most people would consider it middle to higher tier equipment. What do you think that is? What? Something going on, isn't it? Well, here's what's interesting. Look at how evenly spaced these peaks are. Nah, it's too wide of the span is from 1 megahertz to 500 megahertz, so it's pretty wide. Now, you can't see it. I'm kind of holding it like this. So you got this antenna. You can kind of see a little bit right there, but it's configured exactly like this. You guys probably can't read. It says it's at 28.2 megahertz. 10 meter band. That's actually what I'm picking up in my house when the radio is transmitting on 10 meter FT8 and all the harmonics. Don't have an amp on. And this is not necessarily an inexpensive radio. This is an ICOM 7610, so I'm pretty sure it works well. But that's still what you get for harmonics. But you got to remember, we're 40 feet from the antenna, transmitting at 70 watts. So you're going to see harmonics, and it's a very inefficient antenna for any frequency. So the 10 meter band is not going to be a much stronger signal because, you know, this is not even a 2 meter antenna. Maybe 220 would be where it would be close to resident. My shack runs off of an HP server power supply. Supposed to be really good. People like them. Lots of people use them. It puts out 70 amps plugged into 110. You do a little tweaking to it, it puts it out at 13.8 volts. Now, what this is going to show is distance makes a big difference. This one is me with this, the antenna, about 3 feet away from the power supply. This is with the antenna about 3 inches away from the power supply. But look at the difference right there. But do you think you could hear that difference? I'm going to say probably, but not always. And if you're not moving close enough to it, you might not. And this, I made sure what it was doing. I was transmitting on 10 meter FT8, and that's the signal that it came with. Okay, antennas. For noise that travels very far, like the St. Luke's and Canyon County that I was talking about, or a power line problem, a power pole, how far away from the source might you be and still be able to hear it? Miles. How do you track down a noise source that's miles away from you? Yes, exactly. What kind of antennas are good for direction finding? Brian said tape measure Yagi. What's another good one? Correct? Probably in the computer bag still. Where is it? The antenna. Ah, I can't see it. A loop. Most of us, I think, are fairly familiar with how a Yagi works. A Yagi is an antenna with multiple parallel elements. One end will have the longest element. The other end will have usually the shortest element. And it works best pointing from that longest element to the shortest element. That's where it has the strongest signal. Used in fox hunting a lot. Easy to build. You can build a 2 meter version with pieces of tape measure and some PVC pipe. HF, of course, they're a lot bigger. A loop is an amazing antenna for direction finding. I can make a loop a little bigger than this that works pretty good on HF. The neat thing about a loop, it's bidirectional. Now, it's not unidirectional like a beam, Yagi, you can tell, hopefully, the strong signal's that direction. With this, I can tell maybe that it's one of those two directions, but I can tell you it's definitely not those two directions. So you can do that and triangulate to figure it out. Loop antennas are pretty amazing. I know one gentleman in here, at least at one time, had an HF loop antenna, a magnetic loop that he used. You can have one that'll work on 40 meters that may only be, 4 or 5 feet in diameter, and they work really well. The way a loop antenna actually works is here's here. So if I'm holding the antenna like this, back of the room and behind me and stuff at the side is nulled out. So if I'm trying to find the noise source and it's James over here, because you know how teenagers are, they've got to be making noise all of the time. I'm pointed at him, the noise. How do I triangulate? I move over to this side of the room. Uh-oh. So it can't be back there and back there at the same time. It has to be somewhere over there. Work really good with that SDR dongle in your laptop to drive around town trying to figure out where that terrible noise is. Yes. More omni, yeah. You put a vertical element, I'm trying to remember, if the vertical element's on the back, it makes it so it still works off the front, or is it vice versa?
Right, the nulls are on the sides of the loop. Yeah, when you point that at me now, that's the null.
Right, and you put a vertical back here and
no? No, turn it toward me now. Now put your vertical element just between you and the antenna, and it'll,
okay.
now you'll have a stronger signal, my direction.
I haven't played with that part, that's why I don't know. I've played with this before, which is kind of neat. What else can we do for noise? Just like with fox hunting, use a blocking system. If it's your network cable that you notice making noise, what's the smartest thing you can do? What? Maybe, especially if it's not shielded cable. Who's put ferrite beads on cables? Almost all of us that have been in the hobby very long have probably bought a lot of ferrite beads and put it on it. You put a ferrite bead on a long network cable, you've basically stopped the RF, so it's no longer a long antenna. It's now 2 or maybe 3 short antennas. Power leads, put ferrite beads on them.
True, all of your monitors have ferrite beads built into them.
If you notice, most good electronics, good brands, power cables and interconnecting cables have 1 or 2 bigger spots near each end. Those are ferrite beads. It's to stop RFI from getting into the cable or the cable radiating it and causing a problem. One of the biggest issues you may see, and we've got some essays in here and we will test, little wall wart power supplies. Lots of them put out a lot of noise. Take it and wrap the cord a few times through a ferrite bead, and you may eliminate 90% of the noise it's putting out. What other ways can you actually isolate it if you know there's a symbol, a signal source besides an RF bead, a ferrite bead? What? Blocking filters. Has anybody had a problem around here with AM broadcast stations causing problems? It's not uncommon. What's usually the simplest solution? Okay. What a lot of people do is for about $100 you can buy a broadcast band filter and you just put it in line, and that's exactly what it does, is it just filters it out. So, what can we do? If you find a noisy thing, see if you can find one that's less noisy. Yeah, I know. I'm sorry. But you can change that in the next month and a half. Ferrite beads RF filters, band reject filters. What's the difference between a band reject filter and a band pass filter? The old table, don't say anything, please, because I know all of you guys know it. Yes, sir.
One doesn't let a certain band through, one lets nothing but one lets only.
Right. So back when everybody watched broadcast television that was broadcast on a transmitter up by Bogus Basin, one of the channel 2 was really close to our 6-meter band. The general public hated hams when they moved in because every time that Larry would key up his radio, my TV would quit working. One of the two of you would buy a filter and put on, or both, and now all of a sudden his TV works again. Yeah, but we're talking 40 years ago. Notch filters. What's the difference between like a band reject filter and a notch filter? I'm going to pick on you, James, because you know these things.
If I had to guess, notch filters will allow multiple amperams movement, but not radio filters.
Okay. In general, a notch filter is going to be a real narrow filter, so you can filter out something pretty specific. Now, some of our people here could probably sit down in a few minutes and design that resonant circuit to notch out a specific frequency. Some of us would look on the internet and figure out how. Some of us will just order one or talk to somebody. What's one of the simplest ways that we can build a filter? And I had to do this just because of what's coming up here in a couple of weeks. Stub filters. How does a stub filter work? So a stub filter is a piece of coax. You hook it up through a T to your system. That's all it is. Who can tell me what happens as the signal goes through coax, especially every, and I'm going to talk about degrees, every 90 degrees of the sine wave or quarter of a wavelength? What happens to the signal? It inverts. So if you make a filter that is that specific number of wavelengths long that reflects all of the signal back to the source, what you get is, and it's kind of hard to see from here, and I'm going to use this as a pointer. The signal is coming down, going through the T, half of it comes down here, the other half goes out. It gets to the end, which is either a direct open or a direct short, which causes the signal to bounce back, and it goes back up. If there's a 90-degree phase shift in both of those, so if this stub is exactly a quarter of a wavelength long, it's 1 plus negative 1. The answer is 0. It eliminates the signal because it adds the two together and they cancel each other out. How simple is that? It is pretty simple. Now, I don't have in this presentation what the amount of filtering, how many dB of filtering it is. If I remember right, this is a rough guess, 30 dB of information just by doing that, but a lot of it will depend upon what this stub is made out of. If you used 6-inch heliax, 6-inch diameter hardline to make the filter, it'll attenuate a lot more of the signal because you won't have loss in the stub. If you use the tiniest coax you can find that's high loss, it's not going to be as good. Does the impedance of that stub make a big difference in the effectiveness of the filter? What do you two say? No. It really makes no difference whatsoever. What is a type of coax that we can usually find really easy anywhere in modern society? RG6, RG5, 5.9. Cable TV coax. How often have you seen people giving rolls of it away? That's what we're going to use to make our stub filters, is cable TV coax. Speaking of that, who's made their own dipole? What's a cheap wire you can use for a dipole antenna? Actually, it's usually cheaper and stronger. Cable TV coax. Because if you're using it as a radiating element, does the impedance inside the wire make any difference? No, because you're really only using the shield. You know, there's other things to it, but the effectiveness of the antenna is going to be just about as good as any other wire, and it's dirt cheap. What? Oh.
So the bigger the diameter of the radiating wire, the more bandwidth you have.
So using coax like that is better than using wire because it's bigger. And if anybody needs it, we've got some, probably somewhere in the neighborhood of 3/8 to 7/16 cable TV coax, like most of a roll that can be used for making wire antennas. This kind of tells you a little bit. So in the past, our club, we made some stub filters that we take to events. We've now bought more nice little simple can bandpass filters because they're a lot easier to use just because they're 2 inches by 4 inches long. This gives you an idea. If you want to operate on 160 meters and block everything else, you make a stub that is 1/4 of a wavelength long on 160 meters. If you want to operate on 20 and block, operate on 10 and block 20, you make one that's 1/4 of a wavelength long on 20.
Does it matter if you're like the 160, if it's all coiled up? No?
Does it? Yeah. If you talk to the CB guys, it makes a really big difference because you never roll coax up, it affects the signal. If you talk to the electrical engineering guys, they'll tell you that every bit of the signal is inside the coax, so what's going on outside it makes no difference whatsoever. Did you? Yes. There's always leakage, so will it affect? Yes. Will it make a noticeable effect? I'd be willing to bet no. But, 2 or 3 dB on a 40 dB filter, you'll never know. What if you want a filter that operates on 40 meters, but you want to block 80 meters and 20 and 10? What if you take these 2 stubs and put them in series in your feed line? This one will block 20 and 10. This one will block 80. You can put them together because you can just have one filter out. Each one just filters out the frequencies that it says.
How would that work if the end of your stub is either open or short? I guess if it could be open, you could have connected.
Well, so if you notice, some of these are shorted and some of them are open, and it's how it does stuff, and I'm not as good at that as I should be. The ones that we made for the club and that I've used in the past, what we do is we're tuning it. The ones that are shorted, we leave the center out and bend it back into the braid, tune it to length when we're done. I don't think we actually soldered them like we should, but then I dipped them in rubber coating to waterproof it. The ones that were open did the exact same thing. When it was done, dipped it and waterproofed it. And you've seen them in the tote. We've had them for quite a few years. And a T? Well, no, you'd put them in. Right. So you do the line from your radio, the T to the one stub. Yes, it's series parallel. Then you put a little jumper and another T. That's where I say series, and another one. But in reality, if you're looking at the feed line, both filters are in parallel. But you just do a T, short stub jumper, next T, and then down to the filter. Yep, well, the good thing is, I can't go any farther. That was my last slide.
Too, the same presentation was done about RF thing. It was about a half hour one at a club over in Portland. And the guy says one of your easiest, cheapest finders is nothing more than an AM, FM
Yeah.
radio, and just walk around and put it on stuff. And just listen for the noise. Just turn to a spot in the band that's dead and AM like that. Oh, that's not good.
They work really well as long as the noise is coming in somewhere near where you're tuned. If it's narrowband noise, something like this works a little better. And I got 2 of them here if any of you guys want to come and see what things look like. When we make the stub filters, or anybody's coming, we'll use a VNA like this to actually tune them. So if you want, and we can make them much shorter, but if you want one that passes 10 and shorts out 20, we'll start it out as longer than a quarter of a wavelength 10, and you will take your little cutters and keep shorting it till it's where you want it to be on the analyzer. Any other questions? I've talked too much. Yes, sir.
Okay, it's been a while since I played with this. The physical length of the stub, say, when you say a quarter of a wavelength of coax, if I figure out a quarter of a wavelength of, say, a 40-meter dipole, it's going to be, what, 32, 33 feet. The stub, blowing off cobwebs here, the stub of the coax is going to be physically shorter than 32
Yes.
or 33 feet.
And here is why. Velocity factor. Many people will tell you when we talk about quarter wave, it's the worst way to talk about it. You should talk about it in degrees of the sine wave. So if you think 90 degrees, that's how far it travels, but a quarter wave is the same thing. Velocity factor. What's velocity factor of wire, James? Okay. Velocity factor, to refresh everybody's memory, is how much faster or slower, normally it's a decimal, so it's slower, how much slower the electricity travels in the wire than the speed of light. The insulation on the wire affects the velocity factor. Most of our coaxes, and I can't remember which is which, foam filled is like 0.66 for the velocity factor, so it travels at 2/3 the speed of light. And if it has a solid like Teflon dielectric, 0.8 something. That's why I say when you're doing stuff like that, you measure long and then you use something like this to tune it exact, because it can be hard, and if the published specs aren't quite right, which we all know, too many manufacturers make the same thing and they don't necessarily come up with correct specs for what they make. This tells you because you can look at it through RF. Okay, anything else?
Should the stub be near the transmitter or near the antenna, or does it matter?
Depends. What do you... So, here's the issue. Your radio, when you transmit, is wiping out Joe.
I'm okay with it.
You're okay with that. So Joe wants to put it on his. But if we put it on yours, like you're actually operating on 80 meters and he's 40, it might be better to try and block your 40-meter harmonic that you're producing, because all radios will produce harmonics. You can't eliminate them completely. So in that case, putting it close to your radio will do better. In my very limited experience and reading, they say put the filter as close to the radio as you can. 2 reasons. First for that, and second, if any signal is coming back in through the coax, because coax leaks, you're still filtering it out because it's next to the radio. It doesn't have that, 1.25 miles of coax from the antenna that's still operating as a receive antenna for you. That's yours. Any other questions? If anybody wants to look at John's Adjust a J, it's up here. You can read his article. You guys can come play with the essays and take up things. I'm going to reach down here and turn this off so you won't be able to hear me. But I want to see